7.4, the sine and cosine ratios. So this continues from the tangent ratios. So I'm going to just take a look at all of these ratios just holistically. Okay, so we call these ratios, we use the short form SOHCAHTOA. Okay, so with the tan ratio, we know that we were dealing with opposite over adjacent. Okay, with the sine ratio, we're dealing with opposite over hypotenuse, and with the cos ratio, we're dealing with adjacent over hypotenuse. Now, when we take a look at a triangle, when we use SOHCAHTOA, it must be a right triangle. Okay, and whatever angle we're talking about, the opposite side is the side that we can draw an arrow through. The adjacent side is the other side that meets at that 90 degrees, and the hypotenuse is always opposite 90 degrees. Now, I put a note at the bottom here. The opposite and the adjacent sides depend on the angle being used. Okay, so if in this case above we're using x, then the opposite side would be this right here. I just started, okay? Whereas if we were using this angle here, let's just call it y, our opposite side would actually be where this arrow comes, where this red arrow comes, okay? So those two sides depend on the angle being used, whereas the hypotenuse is always going to be a hypotenuse. It's always going to be opposite the 90-degree angle. Okay, you need to find the opposite and adjacent sides relative to the angle used. Okay, so here are the three primary trig ratios. Sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Okay, in other words, SOHCAHTOA. For these questions, I'll always write SOHCAHTOA at the top of my page. And then the other thing is that I will sit back and really question what information is given and what information I need in order to choose whether I'm going to use the sine, cosine, or tangent ratio. Okay, example 1. Find the three primary trig ratios for angle x and express the ratios as fractions and then decimals to 4 decimal places. So, SOHCAHTOA. Those are going to be our three primary trig ratios. So we can start by saying sine x equals, okay, and remember there's two parts to each of these. There's the angle and then there's the ratio, okay, cos x and tan x. When a question asks for the three primary trig ratios, it wants sine x, cos x, and tan x. Now, if we're dealing with x here, the opposite side is going to be 24. So we know sine has opposite over hypotenuse, and the hypotenuse is always opposite the right angle. So this is hypotenuse, this is going to be opposite, and then the 10 is going to be the adjacent. So we can write 26 here. In other words, we get 12 over 13. Okay? Or the ratio in decimals, we can write 0.9231. Okay, cos is going to be adjacent over hypotenuse, 10 over 26. If we want to reduce it, it's 5 over 13. And if we want to write it as a decimal, the cos ratio is 0.3846. And now tan, opposite over adjacent, so 24 over 10. In other words, it's 12 over 5. If we want to write that as a decimal, it's actually just 2.4. So those are the three primary trig ratios for a triangle in question 1A. Now 1B, we're going to set up the question the exact same way. So let's set up sine x equals, cos x equals, and tan x equals. So in reference to x, our opposite side, the side that we can put an arrow through, is 6.4. Our adjacent side is the side perpendicular to the opposite, and our hypotenuse is always going to be opposite the right angle. So SOHCAHTOA. Sine is going to be opposite over hypotenuse. So we have 6.4 over 7.6. Okay. Or if you want to put that into your calculator and express this as a decimal, it's 0.8421. Now, cos is going to be adjacent, which is 4.1 over 7.6. Or as a decimal, we can write it as 0.5395, and that's rounded. Or we can have the tan ratio of x, 6.4 over 4.1. 6.4 over 4.1. Again, opposite over adjacent, and we know that from the last section. If we want to divide these, we actually get 1.56. Let's go 10. Okay, and even though this 9 rounds up to a 10, we have to put that 0 in if we are asked for 4 decimal places. Okay, so there are the 3 primary trig ratios for the angles, the angle x. Now evaluate the following to 4 decimal places. Okay, sine 72. All you want to do is put that straight into your calculator, and we get 0.9511. Okay, cos 55, try that in the calculator, 0.5736. And all we're doing is finding the sine ratio of the angle 72, the cos ratio of the angle 55. So now, part C, the sine ratio of the angle 71, the ratio is 0.9455, and then cos 21, 0.9336. Try those in your calculator. Make sure that you're getting the right answers. If not, you may not be in degree mode, so you want to make sure that the D is highlighted on your calculator, or it may say deg as in degree. Okay, you may have R as in radian, or a G highlighted as in gradient. Okay, we don't want these ones. We want to keep it on degree. Example 3, the football coach detests when people cut across the field. Okay, so we know we have a field. There's our 50-yard line. Okay, but the players know that it's only 133 meters to run the field diagonally. So we know that this is 133 meters. If when the students reach a corner of the field, so let's say the students are jogging, and they reach here, they must take a 55.7 degree angle. So this would be the 55.7 degree angle to cut across. What are the dimensions of the field's length and width? Okay, so we want length and we want width. So let's just break this up and let's just take the one triangle, okay? So we have 55.7, and then let's call this length and width. Okay, so let's use trig ratios. In regards to the 55.7, the length is actually the opposite, and the width is actually the adjacent. Okay, and then the 133 would be the hypotenuse. We have to solve for W and L, so the opposite and the adjacent. Let's take a look at SOHCAHTOA. So for this triangle, we know the hypotenuse. So we know the hypotenuse, and we also know the angle. So when I highlight the angle 55.7, it would be like sine 55.7 or cos 55.7. So we can consider it like the S or the C. So let's use the sine ratio to solve for the opposite side, and then let's use the cos ratio to solve for the adjacent side. Okay, so sine 55.7 equals opposite, which we don't know, so let's call that L, over hypotenuse, which is 133. Let's cross multiply, and remember, when we cross multiply, let's bring that 133 right in the front. Okay, so 133 times sine 55.7. I get L equals 109.87. let's round to 109.9, and that's going to be measured in meters. Okay, now we want to solve for the W, which is adjacent. So again, we know we're going to use cosine 55.7, and this equals adjacent over hypotenuse. So adjacent, which is W, over hypotenuse, which is 133. We're going to cross multiply and bring that 133 in front. And remember, we don't multiply the 133 by that 55.7. So we get W equals 74.9 meters. So we can say, therefore, the length is 109.9 meters, and the width, and this is of the field, is 74.9 meters. And I just want to point something out. So if we were to have taken TOA, okay, so the tan ratio, here's what the problem would be. And if you run into this problem, you'll recognize it right away because you won't have anywhere to go. So if we did the tan 55.7, we would have opposite, which we don't know, so like say L, over the adjacent, which we don't know. We can't solve for this. If we have this just one equation, we can only have one unknown, but in this equation, we have two unknowns. So again, we can't solve. Therefore, you're not going to get anywhere very quickly. You know to try something else. Okay, example 4. Samantha is standing on one side of a 500-meter wide river. Okay, I'm going to draw the river the way we actually saw it before in 7.1. Okay, so we know that the river is 50 meters wide. Okay, directly across the river, she sees a swing hanging from a tree. So here's a tree, and here's a swing. Okay, 18 meters from the swing, she sees a fishing dock. So there'd be the dock here. What is the angle between her sight from the tree to the fishing dock? So we want to know this x. Okay, so let's talk about this. So we know that we're going to use SOHCAHTOA because this is a right angle triangle. Okay, this is our angle. So we don't know the angle. So we don't know either the sine, the cos, or the tan. But we know the opposite. So already we're down to either sine or tan because the cosine ratio does not have the opposite in it. Okay? And we know that the 50 is the adjacent. It has to be the adjacent because opposite the 90-degree angle, that's the hypotenuse. So we also have the adjacent. So we have A. Therefore, we're going to use the tan ratio. Okay? We're going to use tan theta equals opposite over adjacent. Okay? We don't know theta, but we know the opposite is 18 and the adjacent is 50. In order to solve for that theta, we've seen this before. We're going to tan inverse both sides. Remember, we can't divide by tan. So tan inverse of 18 over 50, and if you plug this into your calculator, 18 over 50, you get 19 point, let's go 8. Let's just round to 20 degrees, okay? So therefore, the angle between her sight from the tree to the dock is 20 degrees. Okay, and how far is Samantha from the fishing dock? So Samantha's physically standing right here, and the fishing dock is physically right here, right? So we're actually trying to find the length of the hypotenuse. So we can go ahead and just use Pythagorean's theorem, or we can use another trig ratio. I'm going to practice with trig ratios, but you can use either one, okay? So in this case, we want the hypotenuse, okay? So if we write out SOHCAHTOA, okay? Tan does not have a hypotenuse. We cannot use tan. Now, we actually have 18 or 50, the opposite or adjacent. So in this case, you can choose. So let's just go ahead and do sine. It's the first one there. So sine of 20 degrees equals opposite over hypotenuse. And let's cross multiply, but let's bring the hypotenuse up and the sine 20 down. Okay, hypotenuse equals 18 over sine 20. Okay, and if you plug that into your calculators, 18 over sine 20, we get 52.6 meters. Okay, so we can write, therefore, she is 52.6 meters from the dock. Okay, and that looks right. We have 15 and 18, 52.6. And if you quickly plug that in, 18 squared plus 50 squared, and then root it, you get approximately 53. So just with the trig ratios, the sine, cos, and tan, just with the rounding errors, you're going to just be within, like, say, a whole number of it, and then that's pretty comfortable.